7 is another problem that does not require u substitution. It's just a higher level antiderivative using our basic rules. But it does also get into the idea we do have to find the antiderivative of an exponential function. If we think about the derivative of an exponential function, we learned that it derives to itself times the natural log of the base. All right. We talked about that, but we didn't talk about an antiderivative of an exponential function, so shame on me for that. But if the derivative works this way, then the antiderivative would work in the opposite way, which means, so we can say, so the antiderivative of 2 to the x dx, instead of multiplying by the natural log of the base, we are going to divide by the natural log of the base. And in fact, if we were to derive this, we would get 2 to the x, because the ln 2's would cancel out. I guess that we need our plus c there as well. All right, so 2 to the x natural log of 2 would antiderive, 2 to the x would antiderive to 2 to the x over the natural log of 2, whether it's x or it's t. Oh, shame, Mr. Swain, you lost your differential. We need to see this term, and we see it in both of these cases. So then the question is, should there be a t after the e to the pi? E to the pi is just a number. It's a constant. If this was a 3, it would antiderive to 3t. Since it's e to the pi, it antiderives to e to the pi times t. So a is our antiderivative. All right, again, what happened right there? E to the pi is a constant. So the antiderivative of e to the pi dt will be e to the pi times t plus c. All right, number 8. Now we get to our u substitution. Okay, and if you do this in your head, that's fine. You don't have to write down the u and the du, but you absolutely can. If we do that, we see that we're missing the 3 on the inside, and therefore we need the 1/3 to compensate on the outside. All right, so we have the antiderivative of 1/3. Cosine is not part of the substitution. U cubed, x cubed is now u. And then the 3 and the x squared and the dx are replaced by du. The antiderivative of cosine is sine. That should be a 3 right there. So we have 1/3 times the sine of u plus our arbitrary constant. And we back substitute we see our answer is B. Number 9 looks like u substitution. However, if we make u equal to x squared plus 1, du is 2x, we see that we have a variable which is not present, and we can't do the 2x on the inside, 1 over 2x on the outside, since that will mess up the domain of our solution. So this can't be u substitution, which means it needs to be a little bit of extra algebra before we can do our calculus. We have to expand that x squared plus 1 squared. So we have here x squared times x squared is x to the 4th. X squared times 1, we do it twice, so that's plus 2x squared. And then 1 times 1 is 1. So now we've taken our product and we've turned it into a polynomial. And we can use our basic rules for anti-differentiation. We have x to the 5th over 5 plus 2x cubed over 3 plus x plus c, and the answer is D. 10 does require u substitution. U will be equal to the x squared. Du is 2x dx. We don't have the 2. So we put it in and we compensate on the outside. So we have 1/2 times the antiderivative of e to the u du, which is 1/2 e to the u plus c, which is 1/2 e to the x squared plus c, which is A.